Every winter, millions of homes around the globe are warmed by tiny wood pellets. The fascinating part is that they don't start out as some premium fuel source. They begin simply as sawdust and wood shavings, the leftover scraps swept off factory floors. So, how does something nobody wanted transform into a multi-billion-dollar global industry? And why are more and more people choosing them over oil and gas? Join RaWMachines as we dive in and find out right now. The global wood pellet industry is now valued at between $17 and $21 billion, producing roughly 50 million tons of pellets each year, and growing at an annual rate of nearly 7%. To put that into perspective, 50 million tons weighs more than the combined weight of all the cargo ships currently operating on the world's oceans. So, why is demand growing so quickly? The answer lies in the rise of modern pellet stoves. Unlike traditional wood-burning stoves, where homeowners must split firewood, stack it for drying, and constantly tend the fire by hand, pellet stoves operate with a high degree of automation. All you have to do is fill the fuel hopper, set the desired temperature, and walk away. The system takes care of the rest. Combustion takes place with very little smoke, and the amount of ash left behind is minimal. Maintenance is equally simple. Empty the ashtray every few days and clean the burn chamber about once a week. Compared to hauling firewood and scraping creosote from a chimney throughout the winter, it represents a major step forward in convenience. But how much does it actually cost to heat an entire home with wood pellets through a full winter season? The answer may surprise you, and we'll come back to that at the end. Depending on the scale of the operation, the raw materials used in pellet production can vary significantly. Smaller facilities often rely almost entirely on recycled wood materials, such as sawdust, wood chips, and planer shavings collected from sawmills and furniture manufacturers. Larger operations, on the other hand, typically combine wood waste with timber, sourced from sustainably managed plantation forests. At one of the industry's largest facilities, capable of producing up to 450,000 tons of wood pellets each year, the scale of the operation is truly remarkable. Massive trucks loaded with freshly harvested timber and stream through the gates throughout the day, with hundreds of deliveries arriving daily. Across the receiving yard, the scent of fresh pine resin fills the air. The first stage is debarking. The logs are fed into massive rotating steel drums that strip away the outer bark. As the drums turn, pieces of bark fly in every direction, creating a sound much like rocks tumbling inside a giant steel barrel. Because bark contains impurities that can reduce pellet quality, it must be removed before processing can continue. But nothing goes to waste. The bark is sent directly to the facility's biomass boilers, where it is burned to generate the heat needed for the drying process later in the production line. From the very first step, waste material is already being recycled to help power the operation itself. Once debarked, the clean wood is sorted according to quality. Each grade is destined for a different end product. The highest quality material is used to produce premium pellets with low ash content for residential heating, while lower grades are directed toward industrial applications or animal bedding products. The same raw material can produce very different products depending on how it is processed. Inside the facility, the raw wood material is fed into high-capacity industrial grinding systems. Massive steel hammers spin at thousands of revolutions per minute, pulverizing the material into uniform fragments. The resulting sound is a continuous roar, like thunder echoing against steel walls. The wood dust is so dense that the factory lights dim behind the airborne haze. Following this primary grind, the material is transferred to a secondary milling system for finer processing. This reduction process continues until the particles are down to the size of a grain of rice. Concurrently, a heavy-duty industrial magnet strips away any stray metal debris accidentally introduced during raw material collection, such as nails, screws, or broken saw blades. This is a critical safeguard, as even a tiny fragment of metal could catastrophically destroy an extrusion die worth thousands of dollars. Next comes the decisive stage, drying. The raw wood material typically carries a moisture content of around 45% upon collection. However, to successfully extrude it into high-quality pellets, this moisture level must be driven down to between just 11% and 12%. This critical task is handled by a massive rotary drying system. Inside, a giant drying drum slowly rotates while a continuous stream of hot air is blasted countercurrent to the flow of the wet material. It is this precise combination of heat and airflow that coaxes the moisture out of the wood fibers. Remarkably, many plants require zero external fuel to run these drying systems. Instead, they burn the very bark and wood dust generated during the earlier processing stages. Precise moisture control is absolutely vital. Laboratory technicians continuously sample the material, weighing it before and after heating to determine the exact remaining moisture percentage. Even a minor deviation can cause severe issues during extrusion. If the material is too wet, the pellet mill will clog. If it is too dry, the resulting pellets will be brittle and crumble apart. At this point, what was once raw sawdust has been finely ground, dried, and controlled with high-tech precision. But to transform this loose wood powder into a true solid fuel, it requires one element that outweighs all the rest: immense pressure. The feed pipes deliver the wood fibers, now processed as fine as powder, to a battery of pellet mills. This is the heart of the entire production line, where loose wood dust is transformed into a finished fuel. Imagine a giant garlic press. The wood fibers are forced through thousands of tiny holes, measuring just 6 to 8 millimeters in diameter, all happening simultaneously. As the die rotates, heavy rollers exert immense pressure, compressing the wood fibers by approximately 400% in volume before pushing them through the die openings. From the exterior face of the extrusion die, thousands of continuous pellet strands emerge all at once, resembling a massive brush growing straight out of the steel. An automated knife slices them at pre-programmed intervals, creating uniform pellets about an inch long, or roughly 2.5 centimeters. The internal pressure within the extrusion die is colossal. Yet, what makes this process truly incredible is that there is zero glue, no chemical binders, no additives whatsoever. Absolutely nothing is introduced to hold the pellets together. It is just wood and pure, unadulterated pressure. So, what keeps the pellets from crumbling apart? The answer lies within the structural makeup of the wood itself, as the intense friction of extrusion generates temperatures reaching up to 170 degrees Celsius inside the die. The natural resin remaining within the wood fibers begins to melt. This compound is called lignin, and it acts as nature's own glue. Under the dual impact of extreme pressure and high heat, the lignin liquefies, coating every single wood fiber and fusing them together. As it cools, it hardens, locking the entire matrix into its final shape. In other words, nature provided the binder for the pellets all along. The factory simply activates it through raw compression. Snap a freshly extruded pellet in half, and you will notice a glossy internal sheen. That is the hardened layer of lignin. Pick it up, and you will find it is far denser than the original wood, packed so tightly that it sinks instantly in water. That is the sheer power of 400% compression. Upon exiting the pellet mills, the pellets are still extremely hot and quite tacky. Their temperature is so high that they cannot be handled directly with bare hands. If they were to be bagged immediately at this stage, the entire batch inside would fuse together, solidifying into a single useless block. To prevent this, the pellets are funneled into cooling counterflow towers for roughly 15 minutes. Heavy-duty industrial fans draw ambient air through the bed of pellets, gradually pulling the latent heat out of them. During this cooling phase, the liquefied lignin begins to re-solidify, curing the structure and significantly hardening the pellets. The structural difference is night and day. A hot, fresh pellet can easily be crushed between your fingers. However, once properly cooled, it gains immense structural integrity, resisting deformation under normal crushing force. After cooling, the pellets pass through a vibrating screening system. The screens remove wood dust and undersized particles that do not meet quality specifications. Once again, nothing goes to waste. All of this material is collected and recycled back into the process, where it is used as fuel for the drying system. The certified pellets are then transferred to the packaging department. Here, a fully automated system feeds pre-printed plastic film to form bags, dispenses exactly 40 pounds, or nearly 18 kilograms, of pellets inside, verifies the weight, heat seals the top seam, and simultaneously forms the bottom of the next bag. The entire operation runs continuously, executed with almost seamless fluidity. In the pellet production industry, timing is absolutely everything. Demand spikes sharply in the autumn and reaches its absolute peak during the winter. If supply falls short in January, it is virtually impossible to play catch-up in time. Because of this tight window, manufacturing plants must capitalize on the summer months to run production at full capacity and stock up their inventory. Sealed, palletized, and ready for transit. Yet, the journey of these pellets is far from over. Where will they head next? From the factory, wood pellets are distributed through two primary channels. For the retail market, 40-pound bags are stacked on pallets, loaded onto trucks equipped with lift gates, and delivered directly to customers' homes. For larger orders, pneumatic tanker trucks blow pellets directly into storage bins located at homes and commercial buildings, much like fuel trucks pumping oil into underground storage tanks. A significant portion of production, however, never remains in the domestic market. The United States alone exports nearly 3 million tons of wood pellets to Europe each year, with a total value of roughly $686 million. Massive cargo ships carry thousands of tons of pellets across the Atlantic to countries such as the United Kingdom, Germany, and the Netherlands, where demand for this fuel continues to grow year after year. At the end of the supply chain, inside the living room of a family home, a pellet stove operates almost entirely on its own. The user simply fills the hopper, often capable of holding up to 80 pounds of pellets, enough to provide heat throughout the day. Microprocessors continuously monitor combustion conditions and automatically regulate the fuel feed rate. All that is required is setting the desired temperature and letting the system do the rest. The fire burns with very little smoke, and when the process is complete, the remaining ash accounts for only about 1% of the pellet's original mass. From a factory floor covered in sawdust to a warm living room thousands of miles away, that is the journey of a wood pellet. For many people, the journey of a wood pellet ends here. In reality, however, home heating is just one of many applications for this remarkably versatile fuel. In the livestock industry, wood pellets are used as bedding for horses and poultry. They offer excellent moisture absorption, generate very little dust, and help maintain a cleaner environment for animals. In the culinary world, premium-grade pellets are used in BBQ smokers and pellet grills. They burn consistently, provide stable temperatures, and impart the distinctive wood-fired flavor that many people associate with slow-cooked barbecue. On a much larger scale, power plants are also turning to wood pellets as a partial replacement for coal. This allows them to reduce emissions without having to completely redesign their boilers or rebuild existing infrastructure. But is wood pellet fuel truly green? The answer depends largely on where the raw material comes from. When pellets are produced from sawdust, wood waste, or timber sourced from sustainably managed forests, they can reduce CO2 emissions by as much as 90% compared with fossil fuels. The reason is straightforward. Trees absorb carbon as they grow. When pellets are burned, they release only the carbon that the trees previously removed from the atmosphere. In the ideal scenario, the process becomes part of a nearly closed carbon cycle. Trees grow and absorb carbon. Pellets are produced and used. The carbon returns to the atmosphere. New trees then grow and absorb that carbon once again. The picture changes, however, when natural forests are clear-cut to supply raw material. A harvested forest can take decades, or even longer, to fully recover. During that time, the released carbon is not reabsorbed quickly enough to offset the emissions. That is why the origin of the wood can be even more important than the pellets themselves. A pellet made from wood waste and a pellet produced through deforestation may look exactly the same, but their environmental impacts are fundamentally different. And while the sustainability debate continues, the industry is already developing next-generation fuels with even higher efficiency. One of the most notable innovations emerging today is the black pellet. To produce them, conventional wood is roasted at temperatures between 200 degrees Celsius and 300 degrees Celsius in an oxygen-free environment. This thermal process is known as torrefaction, or mild pyrolysis. The resulting product looks strikingly like charcoal on the outside, but it fundamentally remains wood on the inside. The result is a roughly 30% boost in energy density. While standard wood pellets contain about 17 to 18 megajoules of energy per kilogram, black pellets can deliver between 20 and 23 megajoules per kilogram. However, the single greatest advantage lies in their water resistance. Conventional wood pellets are highly sensitive to moisture. If they get wet, they absorb water, swell, and disintegrate back into powder. This vulnerability has long been one of the biggest bottlenecks in logistics and warehousing. Black pellets change the game completely. They are virtually hydrophobic. You can store them outdoors directly in the rain without worrying about them breaking down. This breakthrough has the potential to completely revolutionize how the industry stores, ships, and distributes product on a global scale. A new technology yielding a more durable, higher efficiency fuel. It is poised to reshape the entire future of the wood pellet industry in the coming years. Now, let's circle back to the question posed at the beginning. How much does it actually cost to heat a home with wood pellets? An average household typically consumes between 2 and 5 tons of wood pellets over the course of a winter. The total cost for this fuel supply fluctuates between $750 and $1,750 annually, which already factors in delivery fees. When comparing the heat output generated per dollar spent, wood pellets cost approximately $15 to $20 per million BTU of thermal energy. This rate is lower than heating oil, which fluctuates between $20 and $25 for the same amount of heat, and is substantially cheaper than propane, which generally sits between $20 and $30. Only natural gas boasts a lower operational cost. However, utility gas pipelines are not accessible in every region. For many residents living in rural or remote areas, wood pellets stand out as a highly competitive alternative. Yet, the ultimate advantage of wood pellets isn't just the price tag. What draws so many people to this fuel is its exceptional price stability. Over the past decade, pellet prices have barely fluctuated, whereas oil prices constantly ride a roller coaster, driven by global economic and geopolitical volatility. A family relying on wood pellets can predict their winter heating bill with remarkable accuracy from one year to the next. That is a level of financial predictability that fossil fuels can rarely deliver. Now, take a moment to reflect on the entire journey that just unfolded. It all started with loose sawdust scattered on a factory floor, byproducts that, in the past, people would simply sweep away and toss into the trash. No one viewed them as a valuable resource. No one imagined they could become the fuel that heats millions of homes. Yet, they were gathered, pulverized down to the size of a single grain of rice, and dried from a wet 45% moisture content down to just 11%. Then they were forced under colossal pressure inside steel dies weighing several tons. In that crucible, the wood's own natural resin melted, flowing out to coat every individual fiber and locking them into their final shape. No glue, no chemicals, no artificial binders whatsoever. It is just wood, pressure, and the laws of nature that have existed for millions of years. Once extruded, the pellets were cooled for roughly 15 minutes. They were screened to sift out any fine dust, and even that dust wasn't discarded, but was instead routed back into the production line. Next came the bagging, palletizing, and shipping straight to the consumer's doorstep. Absolutely nothing went to waste. The bark stripped away in the very first step became fuel for the drying furnaces. The wood dust was recycled right back into the loop. The minimal ash left over after combustion can be used to enrich agricultural soil, and the timber harvested for raw material will be replanted in managed commercial forests, absorbing the exact same carbon released during combustion. There is something truly remarkable about this story. It is an entire industry built from leftovers, a fuel that welds itself together without a single drop of glue, a source of energy born from waste, and above all, a resource that is inherently renewable. From worthless heaps of sawdust to the vital warmth heating millions of families around the globe, the journey of the wood pellet is a testament to how human ingenuity can transform waste into wealth, turning what was once cast aside into a multi-billion-dollar industry. Are you heating your home with wood pellets, cordwood, natural gas, or another energy source? Share your setup in the comments below. And don't forget to hit subscribe to discover how the everyday products around us are truly made. Sometimes the most fascinating stories begin with the very things most people consider garbage. RaWMachines. Thanks you for watching.